Hi all, this is Honey. Welcome back to our channel Code with Honey. Today we are going to solve September Day 10 LeetCode challenge, which is minimum number of people to teach. So, what's the question states? Means on a social network consisting of M users and some friendships between the users. Okay, two users can communicate with each other if they know a common language. So there's a social network which has M users and some friendships between those users, and they can communicate with each other only if they know the common language. Got it? So they will be giving us an integer array n, which consists of languages and an array of friendships where n languages were numbered from 1 to n. Okay, so the languages is a set of languages of I is the set of languages that I user knows. For example, yeah, here they have given 1 2, right? So the first one, the person knows one languages. Person 2 knows 2. Person 3 knows 1 comma 2. So there will be 3 persons, and these are the friendships between them. So friendships of I equals to U of I denote the friendship between the user U of I and V of I. So you can choose any one language and teach it to some users so that all the friends can communicate. So we have to take one language and we have to uh, teach to all of them so that they can communicate. Got it? So note that, and we have to return the minimum number of users you need to teach. So yeah, note that the friendships are not transitive, which means 1 and 2 are friends and 1 and 3 are friends means, and 1 and 3, 2 and 3 are not friends directly until unless they have mentioned here. Got it? Yeah. Now just take a look at the example. Let's take a look. The two examples that they have given the explanation. So let's hear. If you see, the one is having a friendship with two, but they doesn't know the common language. They doesn't have the common language. And one is also had a friendship with the three. Okay, so they have a common language one. So we don't need to make them learn anything. And two also, two has a friendship with three. They also know two. Now we need to either make one learn two or two learn one. Okay, so that they can communicate. So only one here. Okay, so minimum we need to teach us one. Got it? So either we can make one to learn two or two to learn one, so that these both can communicate any one. So only one language. Got it? So now here comes. So here if you see, one having a friendship with 4 and 2. Okay, so 1 and 4 doesn't have any common language, so we need to teach. If here either you have to make this learn 3 or this learn 2, right? So then one has a friendship with 2, so again it doesn't have a common language. So either what we will think, okay, we have to make either has to learn 1 or 2. So now it's like we have to make them learn two languages, right? Also, you have to make them teach only one language they have mentioned. So, what you will teach? You can't teach two languages, right? So, what we can teach these three, what they know the common most three. So, we can make this one user learn three is comparatively lesser rather than making them learn two, right? If you make these two people learn two, then which means minimum user will get increases, right? So if you make this one to learn three, now all of them knows the same language, so now one only will learn three to get the minimum. Okay, so then 1 4 1 2 2 3, all of them now knows 3, so they can communicate with 2 and 3 also okay. Now 3 and 4. See, now 2 here as well what we will be doing, will be learning. So 3. Here also we don't have a language 3. So will be learning. So minimum users here will be 2. Okay, minimum person to teach will be 2 here. Got it? So basically what we are doing, we'll be checking the friendship and what all the languages first person knows, that will map it in a map. Okay, for example here, for we'll be traversing what basic algorithm that I can think of is, first traverse through the friendship. Okay, once you are traversing, now whatever the languages that 1 and 4 knows, if they share a common language, you don't need to make them learn any new language because they can communicate already. If they can't, then you need to add them, because we have to make them teach any one language, right? Across everyone, we have to make them teach one language. So we'll be, what we are thinking, what the idea comes to mind us. So if you keep on, for example, one is has a friendship with 4, one has a friendship with 2, if they can't communicate, you add them in a set. Okay, what all the people that can't communicate, add it and set if they don't have common language. So once you have added, now what all doesn't have the common language, will have 1, 4 doesn't have. Then here 3 and 4 also doesn't have. So already 4 is there, so you don't need to add. So 1, 4 doesn't have, and 1, 2 also doesn't have. So these are the set values that we will be adding once we have added, because 1 and 4 doesn't have a common language, right? The same 1 and 2 also doesn't have, so 1 is already there, so we have to just add it too. So then if you come, 3 and 4 also doesn't have, so 4 is already in the set, so you just add the 3, and 2 and 3 shares the same language, so you don't need to do. So we'll be checking by first traverse this one language and add it in a map, temporary map. So then traverse through the 4. If it is present, if any language is present based on the common various any variable, if it is present, then set it to true and break the loop, so that you know whether the common language is present between both of them. If not, add it into the set. Okay, so that's why we have added this as a. Then once you know the common language is not present, then what we'll be doing now, what all the languages count, we'll be taking count of languages that each person know. Okay, so maximum count will be like maximum people knows the language. So now we will be taking count of the languages that each person knows, right? So let's see. So what all the languages will be, 3 languages, right? 1, 2, 3. 0 will be okay. Now count of 1 is 2, count of 2 is 1, count of 3 is, count of 3 is 2. Either you can make everyone learn 1, okay, or you can make everyone learn 2, because both of them count as 6. Now the length of our intersection is 4. So see, 4 people have friendship that they can't communicate. So out of 4, 2 people knows already the same languages. So what we can do, 4 minus 2 will give you 2, right? Once we get, so subtract the common max count from length of who can't communicate. Got it? So now 4 minus 2 will give us max is 2. Either they can we can make them learn 1 or 3, whatever it is. So 4 minus 2 will give you 2. So answer is 2. Here if you take, let me explain, the set will be who can't communicate with each other. So 1 can't communicate with 2 because 1 and 2 languages are different. So we'll be writing 1, 2 in the set, and 1 and 3 can communicate. 1 and 3 can communicate, they have a common language. So 2 and 3 also communicate because they have so 1 and 2 only. Okay, so in this 1 and 2, now if you take the count of this 1 and 2 languages, so this is count of 1 is already 1, count of 2 is already 1, so you can take any of this count, and this is 2 minus 1. You can make them teach any one language, any one person you can make them teach, either to 1 you can make them teach 2, or 2 you can make them teach 1. Yes, I hope this makes sense. This algorithm is clear to you guys. So this is the exact thing approach that we have used to solve this question. See, we will be traversing through the friendship, and for each friendship will be, for the first languages you will put it in a map. Okay, 2. So if the languages is present in the 4 as well, then common languages is there, they can already communicate, you don't need to make them learn anything, right? So if not common, then we will be adding to the intersection of the intersection is, so they doesn't know anything. So now we will be adding 1 comma 4 to the set. Okay, it is a set. So once we have figured out what all the languages that can't communicate, then we will be taking a count of people who knows the languages. So again we will be traversing from the set. For example, 1, 2, 3, 4 will be our set. We will be traversing through the each languages in the set, and we will be taking the count, and we'll be taking the maximum count. So among that, 4 minus 2 will give you the maximum people who know the languages. If you subtract from the length of the intersection, you have to teach them. We'll be getting minimum number of people you need to teach, right? So yeah, that's what. I hope this makes sense. So time complexity will be, m will be the friendship, and n will be the languages. So yeah, and space complexity is intersection of the languages might be order of m plus count of people will be order of n. So their space complexity will be order of n plus 1, and time complexity will be order of m, because we are traversing each time the friendship which is of length and the languages of length n. I hope this clear to you guys. If you still have any questions or feedback, please do leave a comment in the feedback section. I'm happy to assist. So the GitHub link to the solutions will be provided in the video description for your reference. If you find this video helpful, I would truly appreciate it if you could like, subscribe and share it with your friends. Your support motivates me to do more videos daily. Yep. Thanks for watching.